Okay, so today we're looking at undoing the chain rule, if you will. So we're going to take a problem that somebody used the chain rule on to get the derivative, and we're going to go back and find the original. And if you'll make a little cheat sheet here, it's in your notes, but I want to write it down, okay? So if you're trying to integrate, I'm just going to use the word thing, to a power, then, well, let me write du. Okay, so in other words, I have like 3x plus 7 raised to a power. If I have a big thing like that. Or if you see e to a thing, right? Or if you see 1 over a big thing raised to a power. And really write these down. You're going to want to look at this, write it on separate paper. If it's in your computer, you can't see it. So everybody get paper out. You're going to need these. I'm doing the same list. And when I write the word thing down, what do I mean? Okay. When you see these in our work today that we do, okay, and when I say thing, what do I mean? Thing means not just an x, bigger, like 2x or 3x squared minus 7. So when we say the word thing, right? Now write this down. When we say the word thing, we're talking something is bigger than just x. If it were just an x, you could do it from yesterday. If this were just an x, you could do it from yesterday. So when we have to integrate and we've got something raised to a power, or e to a big thing up here that's more than x, or a thing in the bottom raised to a power, or sign of a thing, I don't mean x, I mean like a 2x in there, or 2x minus 7. Okay, so the word thing, will be replaced with, whoops, a u. Okay, so today what we're going to do, we're going to undo the chain rule. The chain rule, you know, that was kind of icky. So today, instead of looking at big scary things, we're just going to replace them with the letter u. Once they are just the letter u, we can integrate like we did yesterday, right? Because u is very easy. It's like just the letter x. It's very simple. So that's what we're going to do. Okay? Does that make sense? Are you okay starting this? So you want this written down because you want it out to the side. If it's in your computer, then you can't see it while you do your work. So write this down. It will be invaluable. That way you have it on test day in a certain spot. I'm going to put mine on the back side of my other work, right? So everybody got this? Some people took pictures. That's okay, but write it down on paper. I could give you a pop quiz to just show me that you wrote it down on paper, right? Maybe I will. Everybody's here today. We might have a pop quiz at 11 o'clock. Just show me that. Okay. So now we're going to look at this. When you guys look at this, do you see that that is really 3 and a thing raised to a power. Do you see how that's something big? So we're going to have to use U substitution. That's what the name of this technique is, U substitution, because we had the chain rule and we don't know how to undo the chain rule. It's too big and scary. After you use U substitution for a while, you'll be able to do the easier ones without the U because you'll see patterns. So let's start by undoing the chain rule. So let's do the chain rule. If this is my original, what's the derivative of that? I got to go here, right? There's a thing, I go down a power, and then I have to multiply by the derivative of that. True? Well, what happens today, right, is I give you this, right, which is the derivative. And what am I going to ask you to do? I'm going to ask you to take this derivative and turn it back in to what we started with. Okay? What's the derivative of sine of 5x? Well, I take the derivative of sine, which is cosine, leave the 5x alone. Now I multiply by 5. You know we don't leave those that way. When there's a number past this argument, we put it back in front. Today, I'll be asking you to take that answer. Remember, in integration, this is the derivative, and you're going to take it apart and go back to the original, and we call that the antiderivative, right? So we are going to plunge in. Are y'all ready to plunge in? So at the very beginning, all I'm going to ask you to identify is what the U is. So you need your paper out. So let's just identify U. Right now, I just want you to identify U. So this is a thing, right? See how it says thing raised to a power? Is this something bigger than X raised to a power? Is it? It is. So that's going to become my U. Let's go through and write all of our U's down first. Don't do anything else. Okay? Now, what did our directions say about E? What's the U? Look at your list that we made. What's the U? The thing that E is raised to. So what is that? 7x. Right here, looking at this problem, what part of that is the U? Let me help you. Is that really x cubed plus 4x to the first? So what's the U? Look at the one you wrote down. It's in a bottom, and there's only one of them that's in a bottom. So what's the U? This is the only one that's got a bottom. So what's the U going to be? Once you can identify the U, this just turns into yesterday. Okay, what's the U here? Now, it's not this one because the X is just X. What is it? It's something raised to a power, right? It just happens to be cosine. So if something's raised to a power, that's your U. So what's the U on this one? Cosine X. What's the U on this one? Look at your list. What's the U? It is 2x cubed. If you see an E raised to a power, that power is your U. What is the U on this one? Okay. Look over these for a second. Do you understand where we got the U? Do you? Okay. Once you've identified U, your job is to take the derivative of it. What is the derivative of this creature? What's the derivative of U now? Come on, what's the derivative of 2x squared, Joe?
4.
4x. Now, since we're mixing up letters, x's and u's, you have to tell what you took the derivative of. What letter did you take the derivative of here? X. We took the derivative of x. And think about it, you need a dx in there to match that up. Okay, what's the derivative of du? Or sorry, what is du? 7. And you always tell who you took the derivative of. So 7 dx. What's the derivative of this creature here?
3x.
And if you got to add a dx and there's plus signs, we need parentheses, right? Okay, what's the derivative here? Derivative of cosine? Derivative here? Derivative here? And if there's a minus, we need parentheses, dx. Okay, I want y'all to look at this list. I need to come up, don't I? I'm too zoomed in. Look at what we just did. If you didn't finish writing your list down, now you see why we need this list. Tell me if there's any part of this that you don't get. Because I'm going to keep going a little bit. I don't want to stop with just that today.
Can you click on that list back for a second?
Yes.
I didn't get it.
You said a second. Okay. Okay, I'll quit being a kid. Now you see the importance. Take a second to write this down if you need to. There's a high probability we're going to have a pop quiz at 11 that you hold up that you have this. And if you don't, you'll just have a 0. Everybody's here and you can't undo refusing to write down a formula on a piece of paper.
We write it in our notes, like on this one?
Mm-mm. I want it on paper because you need this out while you're in your screen. If you need a colored piece of paper, if you're here, I have colored paper and you could go grab a yellow piece or something so you're in your notebook, you look for the right color. Trust me when I say this is one of the hardest things people think. I think I've found a way to make it easy though. Okay, we are going to keep going. Now I've come up with an acronym. Do you like my acronym? The acronym I'm using so you won't forget to do is called you, do, sir. See, I could say, who does integration? And you can say, you do, sir. Right? Isn't that perfect? You know it is. If I could only remember what you do, sir stood for. I remember. So we're going to go all the way now. We're going to find you. We're going to identify you. Then we'll take du. Once we do u and du, does it pretty much turn into what we did yesterday? Yes. Okay. What's the u here? What's the u? Y'all, what's the u? This is what we did on the page before. Do you recognize it? What's the derivative of that?
4x.
Right? Once we're there, I need everyone's attention because we're going to talk about what we would do with this. We're going to set it up. So instead of writing 2x squared minus 5, I'm going to write u squared. We have to be very careful and go very slowly. This has to click for you. So it might be handy to match up your colors with highlighters so you know who came from where, right? Now, what do you notice about this and that? They're the same. So instead of writing a 4x and a dx down, what could I call that? What can I call it? Du. Take a second and think about what we just did. It's all about the concept. The mechanics are easy. It's the concept. What did we just do? We rewrote this, but instead of calling it something really scary and big, we just called it u, because u is a nice small letter. We still squared it. Now, instead of writing 4x dx, which is big and scary with lots of stuff, we just called it du. Everybody okay with that? So we found u, we found du, we set it up. And what do you think I stands for now? Not iguana. What are we studying? Integrate. I stands for integrate it now. And what's the rule on integration? Power up and divide. True?
Yep.
Okay, so what is this? What is u going to be when we power up?
1/3 u to the 3rd.
You're almost right. You forgot. No.
Let's see.
What did we say happens when we integrate? What happens to the du or the dx when we integrate? It removes it. We better write that down. You could be asked this question on a major exam. Integration removes the rate. And rate means what to us? Derivative, right? Integration removes the derivative. Which part of this is the derivative? The du part, right? Is that okay? So if I said Madison can run, I don't know, 10 miles an hour, is that a derivative or an antiderivative? It's a derivative because it's per hour. That's a rate, right? That's a derivative. She's running per mile. That's per something is a derivative. It's a rate. If I said Madison ran 21 miles, does that come from an integral or a derivative? Integral, because the per miles, it's actually how far she went. I want you to really think about that, because this today is just mechanics. It's going to lead us into application problems. And when you get to applications, you've got to pick derivative or antiderivative. Do I integrate or do I take the derivative? And what you're looking for is going to help you with that. If you're going miles per hour, you're already a derivative, right? Okay. All right. Now, everybody okay with where this came from? We powered up and divided by 3. What do you think R stands for? Rewrite now or replace. And we are going to replace the u with what? What's going to go in place of u? What? 2x squared minus 5. Now, did we do this correctly? How can I tell? So, set up, integrate, replace. You do, sir, gives you a list. Can you tell me how I can check that to see if it's correct? Yes. If I take the derivative, what should I get? I should get this that I started with. Let's take the derivative. What's the derivative? What's 3 times 1/3? Now take derivative that you're an expert at. So 3 times 1/3 is just 1. 2x squared minus 5 squared times the derivative. What's the derivative of 2x squared? 4x. And what letter did we take the derivative of? Did we go back to the beginning? Did we get back to where we started? Does this match this? So did we do it correctly? Yes, we did. What do you think? Not too bad? You do, sir, is my own creation. You won't find that in the books. All right, let's try another one. What is the U? 7x?
No. Wait, why do I have 4x? I don't know what 4x is.
Should that be a 7? No, it's this is the one we did first. Did y'all say 4?
Wait. This is 4x.
Are you on the right page?
No, I'm not. I just did a whole
Okay.
problem without that.
Okay. So what is the derivative? So now what are we going to do? Set it up. So what is this now? You're going to rewrite it. Now take the derivative of this. Let me see how many of those I have for you. Y'all take the derivative. I'm looking to see if I have another one of those.
Is your different? No, we don't have this.
You don't have this page?
No.
Okay, well, I did a sample for you. Do you have this page next?
That's the one, that's the one. That's the one I was doing, yeah.
Okay, that's okay. I could do this page. I don't have to do the other ones. Okay. We just did this one though, right? That one was the same. Okay, we'll do this one. No problem. Sure. I have extra pages. I don't know why. What's the U? What's du? Now we need to set it up, right? How do we set that up? Well, let me ask you something. Is it legal, and may I please, can I factor a constant outside? Yes, that is legal to factor a constant outside. So I'm going to put the 5 out here. So this is really 1 over e to the u du, correct?
Mhm.
How do I integrate that? How can I rewrite that so I can integrate it? How do y'all do a variable in the bottom? How do you take the derivative of that? How do we integrate that? Can I say this? Can I work without something in the bottom because that's just too scary? Okay, so let's integrate that. What do you get when you integrate? Are y'all awake? Okay. I feel like what is this going to be when we integrate it, guys? What's the antiderivative of e? We don't have to think of that. What's the derivative of e to the x? E to the x. What's the antiderivative of e to the x? E to the x. So what is the antiderivative of this going to be? We've got that -1 that has to go in front, right? So what's going to be the antiderivative of this? The antiderivative of e to the u would be e to the u. What's the antiderivative of e to the negative u? Negative e to the u. Okay. Now, can I factor a negative sign outside? Right? Are we okay with that? Right? Now, we're going to have to make an adjustment here. What is du? Oh, why did I write du there? That's an x. Sorry. What is du? 4dx. Okay. So when we look at this problem, we wrote du down. Du is 4dx. Okay. So this du is this, but there's an extra 4. Do you see how this du now holds an extra 4 that wasn't there before? So this right here is this right here, correct? And this 5 is right there. But this du, right? This du is really a 4dx. And there's a dx up there, so it's replacing the dx, but it's also bringing a 4 with it. So if I'm bringing a 4, what can I multiply by to offset a 4? 1/4. So we need to put a 4 on the bottom because this du brings with it 4dx. And in my original problem, I just have a dx. I don't have a 4dx. It doesn't match up perfectly. So when you integrate using U substitution, you always, whatever du equals, this thing right here, right? This guy right here. When you take the derivative, if there's anything extra there that wasn't there before, you have to offset it. So if there's an extra 2, you're going to have to multiply by 1/2 because then it gets rid of it. If there's an extra 4, you have to multiply by 1/4 to get rid of it. Does that make sense? Are you sure? Okay, so now we're going to rewrite this as what? -5/4, right? Times 1/e to the 4 plus c. This one's kind of hard. Are you okay with that? Okay, I'm going to do this one next because it's a little bit easy. It's another e and I want to keep the same right now. So let's run through the process, and now you know in your head that when you look at this matchup right here, if this guy brings anything with him that wasn't in your original, you have to offset that. Because you can't start with any, you can't end with anything you didn't have. Okay, what is the u? What's the u here? X cubed. So what is the du? 3x squared dx. Now let's think about that. Right? Let's set this up, and what's going to go in there? I have e to the u du. Now we got to look and see if everything matches up. So look very carefully with me. E to the U, right, is this. True? Is that true?
Yeah.
Okay. What is du? Du is 3x squared dx. So du covers the dx. It covers the x squared. What do you notice we have an extra of? We have an extra 3 that wasn't there before, correct? So how do we offset this extra 3 that we're bringing in? 1/3. Does that make more sense? I think this one's easier to see than that one. Okay, so now we integrate. What is e to the u integrated? What's the antiderivative of e to the u? E to the u plus c. When we remove the integration, the integrand, we remove the du. And now what's my job? What does R stand for? Rewrite and replace u with what it really is. Is that okay? Is that all right, y'all? Are you okay? I'm going to do one more that's easy to see before we do this trig one. I don't want to overload you. This one is pretty easy because it's just x's. Okay? So y'all tell me what the u is on this thing. It's going to be your bottom, right? What's the du? Is everybody okay that far? Now we have to set it up. So what are we going to set up? The u is on the bottom, and we're going to write du. Now you have to go look and see if everything matches up. What is u? U is x squared plus x, so that's this part. That looks good, right? What is the du? Du is 2x plus 1 dx. Is that matching up exactly? Does it match up exactly? 2x plus 1 dx. So did we bring anybody extra with us this time? No. So is there anything to offset? Is there? No. So now we can integrate. What do you get when you integrate 1 over u? Now think about that. It's on your special list from yesterday. What's the antiderivative of 1 over x? ln x plus c, right? Remember when you have something to the first power and you integrate it? Then we rewrite it, replace it, and instead of u, we write what u is. Is that okay? Are we okay? I think what I'm going to do is stick to the regular ones in the e's, and then we'll wait and do trig functions next time. I'm looking at faces that look overloaded, and past experience tells me sometimes u substitution's tough. Let's do this last one here, because this is really day 2 of the notes anyway. All right, what are we going to call u here? What's du? 3x squared what? Now we're going to set it up, and that's going to be what? Du. Now, before you move on, make sure everybody matches. So what is e to the u right here? What part of the original is that? It's that right there, right? Now, what is inside du? du is, are y'all looking? 3x squared dx. So that's 3x squared dx. So do we have an exact match here? We have an exact match. So now, what is the antiderivative of e to the u? E to the u, right? And now we're going to rewrite that. Right? What do you think? All right. I'm going to pause and I'm going to let y'all try to do this last one. Okay. And then I will join. Okay. So this matches up perfectly. So now we're going to integrate. What do you get when you integrate 1 over u or 1 over x? ln x plus c. And now we rewrite, and what goes in there? Whoops. What did I do? I said x instead of u. Now I put my u back in there, and u is t squared plus 3 plus c, right? Now, is this one going to be an ln x? Is it? No, because it's not raised to the first power. So y'all take a minute and try that one. All right. What is the u? Anybody have trouble choosing your u now? Okay. What is du? Uh-oh. Now let's think about this, okay? I think that could be trouble, but let's just think. You know that matches up with this. Does this match up with that? I got a dx and a dx, but this is different. What do you think we should be thinking of? Yes, that's really 2 times x plus 1 dx. Now I want you to look at this. Here's x plus 1 dx. There's x plus 1 dx. So what are we bringing with that's extra? Yes, you guys tried to sneak an extra 2 in. Extra from original. That's extra. What do I multiply by to get rid of an extra 2? 1/2. So I need a 1/2 out there to undo that. I can't bring extra stuff, right? It's like the airlines. You only get so much in your bag. Now, what's going to go in here? 1 over u squared du. Let's make sure everybody matches up now. There's u squared, which is this guy right here. Here's du, and du is x plus 1 dx. There it matches, and I'm offsetting that 2 with a 1/2. Am I okay? Okay. Now integrate that. How do I integrate that? Help. What should I think of that as? Right? Now we integrate. What do we do to integrate? Put the words in your head, power up, and divide. So it's going to be 1/2 times 1 over whatever we divide by, right? What do you do when you power up? What is this going to be? What's 1 up from -2? -1 divided by -1 plus c. So what do we have out here? What's 1/2 times -1? -1/2. And what's u? What if you feel iffy right now? What if you're not sure if that's right? What can you do? What do we do? Check by what? I want to check this one and then I'll let y'all work. Check by taking the derivative. So let's take the derivative of this guy. How do you take the derivative? You multiply by the front, power down, and take the derivative of the inside, right? So what's negative 1 times 1/2? We leave this alone. We go down a power. What's negative 1 minus 1? Now we got to multiply by the derivative of the inside, which is what? 2x plus 2. And we took the derivative of x. Now, what's 1/2? Let's rewrite this. I want y'all to really see this so you'll be a believer. You know I don't believe anything till I'm proven mathematically. Okay, this goes to the bottom. Now what happens? I don't really have to write a 1 there, correct? What happens with this 2 and this right here? Is this really 2 times x plus 1? Yes? Now I can cancel those, and I'm left with x plus 1 over x squared plus 2x minus 3 squared dx. Is this what I started with? Does it match exactly? Let me write down what that is. Is this what we started with? Yes. So you know you are right. Okay. We're going to end that for today.